Alright, so in this video we're going to talk about CyFlex's data logging application known as Flogger. We've got a couple. We've got Flogger, D-Logger, and Hogger. I guess that's a few. But for this video we're going to talk about Flogger. That's the one that's most commonly used. So if you go to CyFlex.com and then Help and Docs and CyFlex Manuals, you'll end up here. You can scroll down and you can open this user manual. And then you can read this and learn about our Fast Logger application. I recommend it. There's a lot of good info in it. I'm not going to read it in this video. What I wanted to do is, at a high level, just kind of show you what I actually do personally whenever I'm creating a new log file to solve some new problem for a customer or for myself. So I'm sitting here in Visual Studio Code in a bash window. If you've never done this, you can say terminal, new terminal, and you can actually run your terminal directly from here. For the purposes of this video, that I think is pretty useful. So we're in data PC format. This is where log files are going to log by default. But for now we're going to go to specs and we're going to do an ls on log, simply to point out that you're going to notice at most places there's a standard to call log files logger underscore spec or specs. Some people like the S, some people don't. So if you're on a new system, of course, different sites do their file management differently, so this isn't universally true, but this is sometimes a quick way to find out what loggers already exist. And you may want to just copy one of these log files to your new log file if there's one that's already similar, and you know you want similar keywords and similar variables to be logged. That's not what I do. So what I do is I go to the .def directory. So there's a file. Well, if you haven't been there, there's a .def directory as a subdirectory of CyFlex, and we've got all these fun examples that show you the correct syntax whenever you're creating a new file, and you want to have the correct syntax, which you do. So what I'm going to do is copy CyFlex specs.def logger spec.def to specs logger spec dot example. And so logger specs dot example is what we're going to use for this video. And so if you're familiar with the edit command, which opens in edit, you can type code and then give it a file name, and then you can open that file in code. So I'm going to open this file that I just made, and then I'm going to hit Control / and then that's going to split my windows so that I can look at my file and have a terminal. So this .def file, the reason I like to copy it and use it as a template is it's got most of the keywords that I generally use already in it, and it's got some default formatter stuff in there that I like to use, and then it's got all of the other keywords at the top, which I don't like, and so I always cut this and then I move it down here, so that when I open my file the good stuff is at the top. So let's just go over some of these keywords. We start with @description. This is just going to be something that shows up in the header of your log file. We'll show that later. It's not really functional from the perspective of it doesn't have anything to do with your data. You can put whatever you want there. File name. So whenever you're doing what we're doing right now, and you have all the header information in here, it's good oftentimes to just search for that keyword and come down and see what it says for the description. So the @file name, the contents of the CyFlex variable, will be used as the name of the file that will contain the logged data. So this is what your file name is going to be. Here you can see that I've used a computed expression. You can directly use a computed expression in here, or you can update a CyFlex string variable via a computed expression, or however you want to update it, and you can just put that variable in here directly. If you're going to use a CyFlex variable directly that contains the entire file name, you will just put my CyFlex variable, just like it showed in the bottom, no quotes. If you're doing a computed expression like this, then what you're going to want to do as far as syntax is have double quotes here on the outside, and then any raw strings that you just want to put into the file name, you encapsulate in single quotes, and then you can use the plus sign to add CyFlex stuff. So you could put a CyFlex variable name here if you wanted, or in this case I'm using a user function at year, month, day, and then I'm putting a period in between at year, month, day, and at hour of day. And then at the end I'm putting the raw file extension .csv. And we'll see what this ends up being once we actually create the log file. Output path, I think, is actually an optional keyword. I think if you don't put output path, it just defaults to doing /data/PC format. Don't quote me on that, but I think it does. I usually just put it in here because then you know. So output path is the file path that the log file is going to be, and then at file name is going to be the actual file name. Here we have the scan interval. This is how frequently CyFlex is going to capture the variables values and write them to the file. An important thing to note on this one is that if your scan interval is 1 hertz or slower, then it's going to, by default, write that data directly to the disk. If this scan interval is less than 1 hertz, then it is going to store the data by default in RAM, and then whenever you stop logging, it's going to write all that data to a file. If you didn't want that to be the case, if you want to log data fast and write it directly to the disk, then there is a keyword called force direct file write. The caution that you need to have when using this is that using at force direct file write at high scan rates, or high scan intervals I mean, it's going to use a lot of CPU. You're potentially going to run into priority inversion problems. Other programs aren't going to get the CPU they need, and you might have problems. So in general, if you don't have a really good reason to do that, don't. Moving on, start event. If you don't put a start event in your keyword in here, then when you start Flogger, it's just going to start flogging. And so yeah, and if that's the behavior you want, then you don't need this. I generally like to throw all three of these in here. So the start event is what's going to start logging, stop event is what's going to stop logging, and the release event will tell Flogger go away. So it's the equivalent of running slay Flogger on that instance of Flogger. Let's see, so at logging active, this is a logical variable. I believe that if it already exists, then Flogger will update it. If it doesn't already exist, Flogger will create it. So this is something that you can use if you're writing some script or a GP test or a program and you want it to do something only if you're not logging. Then you could use this logical variable and look at the value and say if this is 1 or true, then that means that we are logging and I don't want to do that thing. So you could do it via an @IfTrue keyword or @IfFalse if you wanted the opposite behavior in GP test or event response. You could do it in Gen labels just using if and then the variable value, or the variable name I mean. So if example logger status, then do this, else do that. You can also just gvar it or put it on an operator display so that the operator can walk up and know whether or not it's logging. So this is optional. I generally recommend it. It comes in handy. At packed, this keyword is just telling it to log things in a CSV. And then we've got our scan list. This is the fun part. So these are the variables that you want to log. So if we actually look at the scan list description, you can see there's a couple formatters. You can make it show more or less decimals than is the default format. So if by default you've got a variable that shows 1 decimal place, but you want to log it at 4 decimal places, you could put control speed right here, and then you can use this formatter to make it show 4 decimal places. So the units one, common use case for that, your test cell operators want things in America units, and then your customer wants them in metric units. So you can specify different units for the log file. So you can make it so that by default control torque, let's say, is in pound-feet, but if you want it to be Newton meters, then you can specify in your log file that you want everything to be logged in Newton meters, and then you don't have to worry about converting your data after the fact. So those are some little formatters that you can do. So now let's take some of these variables and, well, let's take our variables. So one thing that you can do when you're adding variables is you can just run dump it and scroll through and say, okay, I want this one, I want this one, I want this one, and you can put them in there. And sometimes you have to do that. Sometimes you can get lucky and play off of the fact that you know the owner of the variable. So for today's example, what this logger is going to be doing is logging all of my gmodbus variables for my for talking to my queue station. So I'm just going to do a gvar on one of them. Actually, no, I'm not. I'm going to do a dump it on one of them. Gant AO1. And this is going to tell me that the owner of this variable is gl_gmod. In this case, that's because I used genlabels to create the variables. So what I can do now is use fdump, and you'll see that fdump, whoops, you can run a use on fdump and see all of the arguments. You can do that on your own time. The argument that I like to use a lot with this one is the owner equals. So this is going to give me all of the variables that were created by genlabels for gmodbus. The reason that I find this helpful is I can then say pipe awk, and then I'm only going to print the first field. And I'm going to do this because I hate typing and I hate clicking the mouse a lot. And so then I'm just going to put these in here. So these are all of my gmodbus variables, and here they are. One other keyword that isn't in the .def by default, which is my fault. I should have put it in there because I think that everyone should do what I'm about to do, is the @registered name. So I like to put registered names in almost anything that I can. There are programs, release task is one. IsNameReady is another program that wants the registered name as an argument. Whenever you've got a lot of loggers running and you want to release a particular one without opening the file, you can maybe use release task and then this registered name that you can just get from synnames. That's one advantage. You can use IsNameReady to know whether or not it's still running. This isn't required, I just like to do it, so I'm doing it. So we're going to save our file, and now we're going to start this instance of Flogger. We're also going to ignore the fact that I have it running. So here's one way that you can kill programs. I'm not going to kill this this PID which is the PWM control. So I'm going to say no to this one. I'm going to say yes to this one. This is the previous version of this file that I made for a previous failed video. So now if I do send -p flogger, it's not running. So how do we start this flogger? Well, we know that it's in the specs directory because we put it there. And then we can run use flogger to read the usage for how we're supposed to start it. And it looks like we can do flogger and then just the file name. There are some optional arguments that we're not going to use, and then we'll just run it in the background. So flogger, full path, and then an ampersand. You're going to get this message that says that you're limited to this number of scans due to available memory. If there's a keyword in here called @max_scans, if you wanted to manually configure that, then you could. You could put @max_scans and say that you only want it to log 1,000 variables before it stops. That's fine. So let's take a look at this logical variable that I talked about earlier that says whether or not we're flogging. So we're going to gvar it, and it says off. That means we're not logging. So let's use our intuition and then set this start event. So set EV. Now let's gvar that variable. It is on. It was off, and now it is on. So we are logging now. It's a beautiful thing. That was easy. Something that's also worth doing is typing ERRS and then P equals flogger, and then see if the logger file that you created has generated errors. P equals is the process name. This is super helpful whenever you've got a system with a lot of other errors. And you can just tell, like we could do some deep dives and figure out, like by process ID, that this isn't the one that's causing my problems. It's another logger file I have, but we also know that I don't have any of these variables that it's showing errors for in my logger file. So that's another reason we know that that particular instance of flogger is not, my instance of flogger that I just started is not causing these errors. So we started the logger. I don't know if we stopped the logger. We didn't. So let's stop it. So the stop event is stop example log. So we're going to set that stop event, and then we're going to see that it's not logging. Great. It works. Excellent. So where's our file? Well, we said it was in data PC format. So if I run date, you can see it's April 23rd, 11:42, and that this one just got written, and this is the file name. So let's just quickly take a look and see if this makes sense. It's log underscore. That's the raw string value that we encapsulated in these single quotes. At year, month, day, well, it is 2025. It is the 4th month of the year, and it is the 23rd day of that month. And then we've got this raw period here, encapsulated in single quotes, in between the output of at year, month, day, and then we've got at hour of day. Well, what time is it? It's 11:43, so this threw an 11 on there. And then at the end, we got a .csv file. Linux doesn't care what the file extension is often, but I mean, it kinda does. And when I say it kinda does, there are programs that are smart and know that CSVs are comma-separated values that you don't want to see in raw text form. So when someone tells you that Linux doesn't care about file format, they're only kind of right. So let's open this in code and see if we can look at it in the most terrible way possible. So here's the example logger description, and here's my spec file. And this is what I mentioned earlier. The reason this is in the header is because we put it right here. Here we have a list of variables, and these are our scan lists. We've got the units of those variables that are not aligned in any way because it's just a comma separated value, and we're in a text editor. $sign to separate that from everything else, and then we've got our actual values. So this is our logged data. Because I'm not a masochist, I don't generally look at these in text format, and so I'm gonna open it with LibreOffice, which I'm pretty sure is installed by default on all of your CyFlex systems. So now everything's aligned, my eyes aren't twitching. Here we can see that the time column starts at 0, t equals 0. There are different time formatters, and that's probably worth, let's see if we can find them relatively quickly. Yeah, there's this @time format. If you want a different time format, you got options, so you can look at these. I almost never do. I'm fine with time starting at 0 when I set start events. So then we've got our variables that we're logging, the units that the variables are in, and that's it. It's fairly straightforward. So this is what you get from our logging program. So let's say that you wanted more precision real quick. I mentioned that you could put these modifiers on here to get more decimal places. So let's do a search on percent because I forget the format 100% of the time. Let's copy and paste it because I have typos most of the time. And let's say we want this variable to show a silly number of decimal places. I want to see 8 decimal places, or 8 numbers after the decimal place. Okay, so we've changed that, we've saved it. If you don't know, whenever you see this little white dot, that means that I've modified the file, and then whenever I hit Control S, it goes away. So when you're in Visual Studio Code, I think it's like an asterisk in an edit, that can tell you whether or not you've saved your file. So let's start this logger again and see if we can get more precision. So let's gvar this. It's off. So let's start the log. Set ev start. Let's make sure it worked. It did. That's good. It would be embarrassing if it didn't. And then let's set ev stop. See if it worked. It did. Okay, so now let's open this file back up. So if we scroll down, at some point we're going to see another header. This is where we restarted it. And you see time starts over at 0. And you also see that we have failed miserably to accomplish our task. It doesn't have any more decimal points. Why? Well, Flogger doesn't know we changed that file. Flogger is just hanging out. It's already read the file, and it's not going to read the file again unless you tell it to. And so there's a couple ways that you can tell it to. One is you can configure your spec file to have this @read spec file event. And then you could just do a set ev, and it would reread your spec file. And if you changed the format or added a variable or removed a variable, it would automatically update it. So that's one way to do it. But I've already started this log file. We've already clarified that Flogger is not just rereading your file for fun. And so if I add that now, it's still not going to work. So what I need to do is I need to kill Flogger and restart it, or slay it, or release it. And so this is the way that I like to do it. I like to have a release event. So send -p Flogger. We can see that I got 2 instances running. Set ev. Now I got 1 instance running. I just released this. So now we're going to launch it again because I've modified my file and saved it. And tells me I've got some scans. Let's just clarify. That didn't work. Copy. so now we've got example logger status is off. We are not logging. So let's set our start event. Wait a couple seconds. Set our stop event. And then let's open our file again. We still have all this old data, and the reason we have the old data is because of the file name. So the file name is log_@yearmonthday.hour, and the hour is still 11:49. The hour hasn't changed. So it's going to keep right into this file. If I stop and start this logger at 12:01, I'm going to get a new logger file. So here we go. Now we've got another header, and down here we've got more numbers after the decimal place because we asked for more precision on this particular variable than we did up here. So we released it, we restarted it, that caused it to reread the file, and then now we get the changes that we made to the file are active. So that's how you do that. Another quick one that let's see, that's the external header. Okay, yeah. Here's where, if you don't want that header to be rewritten every time you stop and start your logger, you can use this @write header keyword, and you can say never, or you can say none on append, and then you'll get one header at the top, but you won't get one every time you stop and start it. Okay, yeah, so that's just an overview of what I do whenever I'm creating a new logger for new stuff from scratch. That's kind of my exact workflow almost every time, unless, as I mentioned, unless there's already an existing logger file that has a lot of the variables I know I want, then I might just copy that one over and then tweak the start event, stop event, register name, file name, etc., so that they're unique, and then go from there. Yeah, so that's Flogger, and if you have any questions or comments or recommendations on tactics that I haven't mentioned, by all means comment on this video with what you know that I don't. Alright, thank you.